See this question. Let capital A be set of all real numbers. Then on capital A they are defining a relation in such a way that the relation will contain ordered pair A comma B only when B equal to A power K. So if that is the relation, then they are asking whether the relation is equivalence or partial order, or the relation is reflexive and symmetric but not transitive, relation is total order. So they are asking some questions on R. So before answering that, you should understand what the relation R is. Now they are saying that R will contain ordered pairs of type A comma B only when B can be written as B equal to A power K for some integer K. So what they mean to say is this one. See this? Now if you have, you can include 2 comma 2 because 2 can be written as 2 power 1. Then you can include 2 comma 4 because 4 can be written as 2 power 2. You can include 2 comma 8, 2 comma 16, so on. Similarly you can include 1 comma 1 or 3 comma 3, 3 comma 9, 3 comma 27, so like this. But then it is for all real numbers. I have taken only few numbers, so it is definitely an infinite relation. So the number of elements in this relation are going to be infinite. But what they are asking is this equivalence relation? So if you have to say that it is equivalence relation, it has to prove three things. One is reflexive, other is symmetric, and other is transitive. Let's see if it can be reflexive or not. So when can we say that it is reflexive? It should contain all the elements of type A comma A. So let's see if elements of type A comma A be allowed in this relation or not. If A comma A has to be allowed, then this A should be written as this A to the power some integer, and clearly we can write A equal to A power 1, and 1 is an integer. Therefore we can say that all ordered pairs of type A comma A will belong to the relation, and therefore it is reflexive. Yes, reflexive is satisfied. Now let's see if it is symmetric or not, if the symmetric property satisfies or not. Definitely symmetric property will not satisfy. The reason is we can show that if 2 comma 8 is present, because 8 can be written as 2 power 3, we cannot have 8 comma 2 because we cannot write 2 as 8 power some integer. We can write 2 as 8 power 1 by 3, isn't it? We can write 2 as 8 power 1 by 3, but just observe this. They have given that it should be an integer, so it cannot be written. Therefore even though 2 comma 8 belongs to R, elements of type 8 comma 2 cannot belong to the relation, so it cannot be symmetric. If it cannot be symmetric, it cannot be equivalence. So R is definitely not equivalence. Now what about partial order? In order to prove that it is partial order, you have to prove this one. It is anti-symmetric, isn't it? Now what is anti-symmetric? You should prove that if you have A comma B, then there will be no B comma A, right? It is already reflexive. Then we have to prove just this one. Now it is obvious. If you have elements of type 2 comma 8, then definitely no element will be present of type 8 comma 2. Therefore it is going to be anti-symmetric. So definitely it is anti-symmetric. Now if you have to prove that it is partial order, then only thing remaining is we should prove that it is transitive. How can we prove that it is transitive? See this. Now let us say, so transitive will be applicable only when the elements of type A comma B and B comma C are present. Then only we should check whether the element of type A comma C is present or not. So that is why I am just seeing if the elements of type A comma B and B comma C are present. See this? 2 comma 8 can be present and 8 comma 64 can be present. These two elements can be present, isn't it? Why? Because 8 can be written as 2 cube and 64 can be written as 8 square. So these two ordered pairs can be present individually in the relation. Now when I combine them together and see for transitivity, then A comma B is present and B comma C is present, and therefore A comma C should be present, which means 2 comma 64 should be present, and yes, it will definitely be present. Or if you want to write it in other terms, see this. Let us say A comma B is present. What does it mean? It means that B is equal to A power K. And let us say B comma C is present. What does it mean? It means that C can be written as B power L, something like this. Now definitely I can write like this. In place of B, if I substitute a power k, then what I get is C is equal to a power k power L. So which means C equal to a power kl. Got it? Then what does it mean? If C equal to a power kl, we can say that a comma C is definitely present, because if k and l are integers, k into l will be integers. You can see that as proof, or even you can see this one also as proof. Therefore, if you have a comma b and b comma c, definitely a comma c will also be present in the relation. So it is definitely transitive. So it is reflexive, antisymmetric and transitive. So we can say that it is partial order. Look at option number C. It is saying that it's reflexive and symmetric, but it is not symmetric, therefore it fails. Look at option number D. It is saying that R is a total order. Total order means every pair, or if you take any two elements from A, from the given set A, then they should be related. But then it is not true. Why? Because I cannot relate 2 comma 3. I cannot write 2 comma 3 or 3 comma 2, which means these two elements cannot be related. I cannot write 3 as a power of 2, or I cannot write 2 as a power of 3. Therefore, there will be no relation between these two elements whatsoever. So we can say that it is not a total order. So it is only partial order. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay, IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities or 50 lakh universities, but whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is, we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.